Hello, students, and welcome. Today, we're going to revise the very first chapter of your chemistry syllabus, Matter in Our Surroundings. We'll go through it together, step by step, to make it really simple, clear, and very easy to remember for your exams.
You know, exams can sometimes feel a little stressful, but trust me, chemistry becomes much simpler once you understand the main ideas. So, our goal today isn't just to memorize some facts. No, it's to really see how everything in this chapter is connected. That way, you'll be able to answer any question that comes your way. So, let's get started. So, here's our plan. We'll start with the absolute basics, the building blocks of matter. Then, we'll look at the three states of matter and see how they change from one to another. After that, we'll spend some time on those tricky why questions that you often see in exams. And finally, I'll share some simple tips to help you get the best possible marks.
All right then, let's begin right at the start. Section 1, Matter's building blocks.
So, first things first, what is matter? Well, the definition is simple. It's anything that has mass and takes up space. Just look around you. The air you're breathing, the water you drink, the book in front of you. Yep, all of that is matter. And the single most important idea in this whole chapter is that all this matter is made up of extremely tiny particles.
Now, these tiny particles have three main characteristics, and these 3 points explain everything else. First, there is always some space between them. Second, they are never ever still. They are always moving, which means they have kinetic energy. And third, they attract each other, almost like little magnets. If you can just remember these 3 points, you have the key to understanding this entire chapter.
Okay, so now let's see how these particle characteristics give us the three states of matter we know so well: solids, liquids, and gases. The only difference between an ice cube, a glass of water, and the steam from a kettle, it all comes down to how their particles are behaving. So, here's the secret. Whenever you face a question about states of matter, just think about two things. First, the energy of the particles, which makes them want to fly apart. And second, the attraction between them, which tries to pull them together. It's like a constant battle, a tug-of-war. If the energy is very high and the attraction is weak, you get a gas. If the energy is very low and the attraction is strong, you get a solid. Simple.
And this table here summarizes it perfectly. In a solid, the particle attraction is very, very strong, and their energy is very low, so they're packed tightly together and just vibrate in place. This is why solids have a definite shape and volume. On the other hand, we have gases. Here, the particle energy is super high, and the attraction is very weak, so the particles just zoom all over the place, filling whatever container they're in. And liquids, of course, are somewhere in the middle.
So we understand solids, liquids, and gases now. But how does matter actually change from one state to another? Well, it's pretty simple. We do it by changing the temperature or by changing the pressure.
This diagram shows the whole cycle beautifully. When you supply heat to a solid, it melts and becomes a liquid. We call this fusion. If you keep heating the liquid, it boils and turns into a gas. That's called vaporization. Now, if we go the other way and cool it down, the gas condenses back to a liquid, and that liquid can freeze back into a solid. And there's a special case, sublimation, where a solid can turn directly into a gas, skipping the liquid state completely.
Now, here's a very interesting question, and a very common one too. Think about it. When ice is melting, you are constantly supplying heat to it. But if you check with a thermometer, the temperature stays at 0 degrees Celsius until every last bit of ice is gone. So, if the temperature isn't rising, where is all that heat energy going?
The answer to that puzzle is a concept called latent heat. The word latent just means hidden. So this is hidden energy. It's being used for a very specific job, to overcome the forces of attraction that hold the particles together. So instead of making the particles move faster and raising the temperature, all that heat energy is busy breaking the bonds that make ice a solid.
And this idea of latent heat explains a very famous exam question. Why do burns from steam feel much worse than burns from boiling water, even though both are at 100 degrees Celsius? Well, it's because the particles in steam have absorbed a lot of extra energy, the latent heat of vaporization. So when this steam touches your skin, it doesn't just give you the heat from 100 degrees, it also releases all that extra hidden energy, causing a more severe burn.
Okay, let's tackle a few more of these common why questions. This section is all about a very important process called evaporation.
First, let's be very clear. Evaporation is not the same as boiling. Evaporation can happen at any temperature. It only happens from the surface of a liquid. And most importantly, please remember this, evaporation always causes cooling. This is a key fact.
So let's apply this idea. Why does your palm feel cool when you put some acetone or maybe some sanitizer on it? Think about what's happening. For the liquid acetone to evaporate, what does it need?
Let's break down the answer step by step. The acetone particles need energy to evaporate, right? They get this energy from your palm, so the heat from your hand is absorbed by the acetone. This heat energy is used as the latent heat of vaporization, which gives the particles enough power to escape as a gas. And since your palm has lost heat, it feels cool. It's that simple.
Here's another classic question that uses the exact same logic. Why is it always advised that we should wear cotton clothes in the summer?
Again, the answer is all about evaporation. In summer, our body sweats to cool itself down. But for that cooling to happen, the sweat must evaporate. Now, cotton is a very good absorber of water. It soaks up the sweat from our skin and spreads it out over a larger area. This exposure to the air helps the sweat evaporate much faster. And as it evaporates, it takes heat from our body, making us feel cool and comfortable. All right, we have revised all the main concepts now. So for our final section, let's quickly go over some simple tips on how you can present your answers in the exam to get the best possible marks. So how do you write a really good answer? First, always try to use the correct scientific terms, like kinetic energy or latent heat of fusion. Second, explain your reasoning in a logical, step-by-step way. Third, and this is a great tip, always try to start your answer by talking about the particles, their energy, and the forces between them. It shows the examiner you understand the basics. And finally, don't forget to underline your key words. This little habit makes it very easy for the examiner to see that you know the main concept.
And that's it. We have covered the entire chapter, and I really hope you can now see how all these ideas are connected to each other. You have the knowledge, you understand the concepts, so please go into your exam with confidence. You are well prepared. All the very best to you.